Hello, this is Madhumita Ramachandran. In this video, I'm going to talk about single factor ANOVA and Tukey Kramer test. This flowchart helps you recall our class lectures where we learned a group comparison test for two independent samples that came from normal population with possibly different means but the same variance. Here the hypothesis H0 mu1 is equal to mu2 is tested. In this video, we test similar hypothesis for more than two independent samples taken from normal population with possibly different means but a common variance. Now coming to what is ANOVA. Analysis of variance, often abbreviated with the acronym ANOVA, is a statistical method used to compare the means of more than two groups. Single factor ANOVA. Single factor ANOVA is the simplest type of ANOVA. It consists of a single factor with multiple levels and each level has its own response. It is always good to understand ANOVA for the first time with an example. Now let's look into an example. Folacin is the only B vitamin present in any significant amount in tea. Consider the accompanying data on folacin content for randomly selected specimens of the 4 leading brands of green tea. In this example, there are 4 different brands of green tea and the amount of folacin content for randomly selected specimens of the 4 leading brands of green tea is given. Here the single factor is the green tea and the levels are the 4 leading brands of green tea and the response is the folacin content. Factor is always an independent variable whereas response is always a dependent variable. Here the folacin content depends on the brand of green tea. Here we test whether the true average folacin content is the same for all the brands. Hypothesis. Null hypothesis states that true average folacin content in all 4 brands is the same, and the alternative hypothesis states that folacin content differs at least in one of the brands from another. Test statistic. Here the test statistic is the ratio of between sample variation to within sample variation. In between sample variation, we look for the distance of the sample mean from the overall mean, and in within sample variation, we look for the internal spread of each sample. Therefore, the total sample variation is equal to between sample variation plus within sample variation. At this point, it is good to recall the formula for variance. So as to understand the formula for variation, the numerator is the sum of the squared deviation, which is also called as variation, and the denominator is the degrees of freedom. Therefore, variance is the average of the squared differences, also called as mean square. Between sample variation. This is the formula to calculate the between sample variation for our example. We find summation x for all the brands to find out the correction factor. We then substitute the respective values in the formula to find out the between sample variation. We then calculate the total sample variation using this formula where we find the summation x square for all the brands and we substitute in the formula along with the correction factor to find the total sample variation. Within sample variation is calculated using this formula. Coming to F distribution. ANOVA follows F distribution. F distribution is used in the statistical test that involves the ratio of two variance measures such as the mean square between samples and mean square within sample. Mean square between samples is calculated using this formula where degrees of freedom 1 is equal to number of levels minus 1, and mean square within samples is calculated using this formula where degrees of freedom 2 is equal to number of observations minus number of levels. So now we calculate the F0. Now it's time to calculate F critical values. We find the F critical values from the table. For alpha is equal to 0.05 and the F critical value is found to be 3.10. Here you can see that the calculated F value lies in the rejection region as the calculated F value is greater than the F critical value. This is the summary table of ANOVA and the P value is found using Excel and we reject H0 if our p-value is less than alpha and if our f0 value is greater than our f critical value. So this shows that our p-value is less than alpha and also our f0 value is greater than the f critical value. Therefore we reject H0. Interpretation: H0 is rejected means the Fallacian content differs at least in one of the brands. So we do multiple comparison tests as the follow-up test to determine where differences lie. Tukey Kramer method is one such multiple comparison test. Tukey Kramer method is applied when we have unequal sample sizes, and Tukey HST test is applied when we have equal sample sizes. So the Tukey procedure uses another probability distribution called studentized range distribution, where q alpha k n minus k is the upper tail alpha critical value of the studentized range distribution. This is analogous to f alpha k minus 1 and n minus k, where in f distribution we use k minus 1 as the degrees of freedom 1. Here k is the degrees of freedom 1. Hypothesis. So this is the multiple comparison test, meaning we do pairwise comparisons. Since we have 4 levels, we have 4C2, that is 6 pairwise comparison, and for each pairwise comparison we have the null and alternative hypothesis. So the null hypothesis states that mu I is equal to mu j, and the alternative hypothesis states mu I is not equal to mu j. I and j are two different populations. This is the formula to calculate the critical range for each pairs, where q value is found from the table and MSW is the mean square within, which is found from the summary table of ANOVA, and Ni and Nj are the number of observations in population I and j. First we find the q value from alpha is equal to 0.05 table. So it is 3.958. So step 2, we calculate the critical range and the difference in the sample mean for each of the pairs, and I have shown you how to calculate the critical range and the difference in the sample mean for pair 1 and 2. In step 3, we compare the critical range to the difference in the sample mean. First we arrange the sample means in increasing order. Then we underline those pairs that differ by less than the critical range. Start with the smallest mean, x4 bar. We compare x4 bar with x3 bar, and we found that the difference in the sample mean is less than the critical range. So now we move on and compare x4 bar with x2 bar, and again the difference is less than the critical range. Finally we compare x4 bar with x1 bar, and we find that the difference in sample mean is greater than the critical range. So we indicate this using underscore pattern. We connect x4 bar with x3 bar and x2 bar, and now we move on to x3 bar and we make similar comparison where we compare x3 bar with x2 bar and then with x1 bar. So we find that the difference in the sample mean is again less than the critical range for both x3 bar and x2 bar, also with x3 bar and x1 bar. So again we connect x3 bar with x2 bar and x1 bar. Conclusion is we reject H0 if the difference in the sample mean is greater than the critical range. So from this underscore pattern we can find that x4 bar is not connected with x1 bar. So any pair of sample means not connected by an underscore, that is differing more than the critical range, implies a difference in the corresponding population means. Therefore the interpretation is that the Tukey Kramer method indicates that the difference between the true average Fallacian content in brand 1 and brand 4 is significant. Hope you all enjoyed watching this video. Thanks for watching.